So if we want to look at the different types of loft conversions that you're probably going to come across in the UK, I mean, I'm not sure. I know in America there's a lot of timber frame. I think they do have trusses. So if we just sort of park the idea of timber frame in a minute, because that is more complicated when you're sitting on a timber frame. But when you're looking at your typical loft conversion, you've got predominantly two house types. Let's draw this rough. Keep the angles or anything like that, because I'm just guessing. So let's draw a couple of roofs. Roof shapes. So we go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Again, this is just get started. So okay. So if this is your house in section to a house. Same again, section to a different house. So if this was 1900s house, this it's 1980s house. So this was a typically, let's say it was a 2-bed terraced house, which we looked at before. This is say a 3 or 4-bed detached. So what you'd have is, this one is log-bearing masonry, outside walls. Then you typically have one more internal wall, which is load bearing. Again, probably half brick thick. This will be a full brick. And then you'd normally have another wall at the side of this, which is non-load bearing, but it's a stair wall, so that's what you get to sort of come up. But ignoring all that for the minute. So the way the roof is formed is they built the walls, and then they come up and they put on the ceiling joists. And what they'll do is they'll lap them at this point here. There'll be timber plates sat on here. Same on here. The timber plates sat on here. And I can go through all these other details in more detail on other videos, but for now, so if we try just look at the overall principle. So you'd generally have ceiling joists. You're going to have rafters. Normally 4x2, 4 inches by 2 inches. Now in modern money, 100 by 50s. And then what you have is you have timber purlins that they put up, and then they prop them off the ceiling. And you could have on here, you could have a binder that goes between the two, between the length of the roof, and the props just come off that. So you've got ceiling joists, props, purlins, rafters. And that's a binder. That spreads the load of the props. Spreads the load of the props between all the ceiling joists. So essentially all the load is coming down onto this point, and this point. So cut and pitch. May get a collar, may get colours every now and again, may not have colours, possibly. So that's your basic cut and pitch roof. So cut and pitch, because they literally cut the timbers, and then pitch the rafters. Ceiling, props, rafters go up, bang, put the roof on. Now, in a more modern roof, it came the invention of prefabrication and trying to do things off site. We had factories that could make things more precise and repeatable in a factory. So somebody came up with a neat idea of, why don't we make the trusses off site? Excuse that, it's a bit wonky, but anyway, you get the gist. So they're trusses. So these are prefabricated trusses, and typically at 400 or 600 mil centers, and they span between there and there, and these are normally cavity walls. Well, they will be cavity walls in an 80s house. So as you can see, the difference is here, this has got shorter spans. These are typically sort of 4-meter rooms, everything spanning 4 meters, 2-meter props, 2-meter ties, and everything's spanning a lot less. Whereas with a prefabricated truss, you can go 8 to 10 meters easily, not up to 12, but not 8 to 10 meters. And what that means is that any walls that are in at first floor, they're non-load bearing. So if you ever go and do a survey of a modern house, quickly pop your head up into the loft hatch. You typically have a loft hatch up into there. Have a look in there, and then you can see, if you see fabricated truss, and the way you can tell that it's prefabricated is that all these joints have got gang nail truss plates, which are like little metal trusses with lots of little nails in, and they go and they join, splice together timbers. Sometimes you'd have them like shaped like a T, like that, and then everything, that one's spliced there, then that'll be spliced there. So you'd have these prefabricated trusses, and they can span a long way, and it means that all the walls at first floor are normally going to be nominal bearing, just partitions. Sometimes the block work. Some of the more sort of fancy builders built non-load bearing walls but in block work, so it can be a bit deceiving. But if you pop your head up, if you see the fabricated truss, pretty much know it's going to be spanning to external walls, and anything inside is non-load bearing. Right, so how do we go and convert that loft? Well, with the cut and pitch roof, it's a bit simpler because you've got more load bearing walls, and you can either go in and you can strengthen these ceiling joists, and then you can go and put in load bearing ashlar walls off those strengthened floor joists, and then you can maybe take these collars out and put a higher collar up here. Therefore the roof is still triangulated. You've shortened the span of the rafters. You've strengthened the floor so that you can take an imposed load from a roof, from a occupation, a bedroom, ensuite or something, and then everything is all strengthened up nicely. So you could do that potentially with just timber. So timber joists strengthened. Design your timber joists to take the weight of half of that roof and half of that span roof. So I call these ashlar walls. That's what I can't remember why they're called ashlar walls, to be honest, because ashlar is masonry. But these are called in loft conversions ashlar walls. Maybe somebody can remember, can put it in the comments. But so that's how you do it. So that's its total timber solution. Now your builder would love this because there's just no steel to lift up. Easy, get your timbers up, put a hole in your roof, maybe scaffold up the outside, hole in the roof, go in, strengthen timbers, bosh, cut a hole, and then build a staircase up to it. Now, this isn't always possible. Your spans might be a bit big, or the layout of what the architect's doing, and the loft is a bit big, or the scale is a bit more than these 4 meters because it's a slightly bigger, older house. And so what you would do then is you could potentially go and put steel beams in here. Just on a terraced house, assuming this is a terraced house, these would span between party walls. So on plan, if you had a row of terraces, you've got party walls between them like this. So steel beams would go in here. Then again, you go and build a low bearing ashlar wall off it. Put in a collar, and then potentially strengthen the rafters depending if the spans work and if everything's fine. So that's how you would go and do it. So the trick with this one is getting your steels in. Obviously on a terraced house it's pretty difficult, but it can be done, because what you do is you just splice these steels. So say your steel was, I don't know, so the house is 6 meters wide. You'd have a steel that goes there and then sits in the party wall on a padstone like that. What you do is you just put a splice in there. And that's typically 2/3, 1/3. I'm smudging. This is the pain of being a left-hander. I've smudged all this stuff, but anyway, let's roll with it. So what that looks like is you have the beam that's cut like this. Then you go and put top flange plates, bottom flange plates. So I've drawn them a bit thick, that's a bit bonkers, but anyway. It's all indicative at the minute. And then you put a web plate. So you'd always have 4 bolts in there. Those get designed for shear, these get designed for the moment. As you probably remember, the flanges, they carry all the tensile force. So you've got your bending moment diagram like this. You've got your maximum moment M in the middle, M max. If it's at a 3rd point, you can get a slightly reduced M. Work out your moment and your shear. And then you do M upon D, D being the depth. And that'll give you your flange force. Then you design your plates to take those forces. But anyway, that's probably gone too far for this video. So yeah, so that's how you would do it. You put in a couple of beams, splice them, lift them in, put them in, and what you can do, and then you can just go on, if you put timber in the web of these, you can then just go and put in new joists, floor joists between there, build your ashlar walls up, strengthen any rafters if you need to, depending on condition, size, blah blah blah, and therefore you got a roof. Still pretty straightforward, still small. Now, sometimes you do have instances where you, depending where the stair is, you can't get these steels in. One of them can't be there because there's a big opening or something. Depends on the architectural layout, and sometimes what you do is you go and put in a ridge beam. Works on the same principle, bring it in thirds, and what that does is then you can design rafters potentially to span from there to there. Pretty beefy, but you can do it from there to there. You often have these as well. Put in a ridge beam if you had a dormer. So you want to go and chop the front out, you wanted a dormer in there, a ridge beam would go in there, carries your rafters, and then you can span a flat roof joist to it and have a load bearing front wall onto your wall below. So that's basically the principles of a cut and pitch loft conversion. 2 options: strengthen the timber or put steels in. And moving on to the more modern, so 80s style house, you don't have the option of strengthening this bottom chord because there's nothing to span onto, because if you remember, these aren't load bearing, so you only really got one option. You've got to go and stick a steel beam in. So you go and stick a steel beam in, but the difference with this is because it's probably a bigger house, it could be 8 meters span for these steel beams, so your detached house is square, rectangular. You could have these beams and they could be spanning a long way. So what you tend to find is these are deeper. So that is 10, say it was 8 meters, span upon 20. So you could end up with a 400 deep beam-ish. But again, same principles. More akin to what I talked about the second option. With that, you'd go and So you're living in the house, so the people are still in there, so that's your first floor. People are still in there. Scaffold up out the outside, crack a hole into your roof, and then your builders can come in and do the work. Getting the beams in is a bit easier. You can actually get them craned in because you can come in from the side, because if it's a detached house you can get in from the side. With the terrace you're struggling, so that's an option. Or again, you can splice them. So anyway, deeper beams, but again, same principle. You go in, build your little bare slab walls. These are really small. The timber members in a truss roof are small, so you're nearly always going to have to strengthen them. So you go in, probably strengthen them, strengthen the rafters, put a collar in, put in new floor joists because you can't rely on these bottom ones. Yeah, and then you've got essentially a tied roof at the top. The collar's not right at the top. This top portion is tied. There's no spread in this because the rafters span from there to there with no thrust. Same again, there to there, no thrust. You've got strengthened floor joists, which are hung off your steel beams, and therefore you've got a loft conversion. So again, the key to all of this with loft conversions is just practicalities. I've seen some bonkers designs, and you probably have on forums on Facebook, and people asking bonkers questions. But the bottom line is, these ceilings are not designed for occupation. Now, people have done it, and I go and do surveys all the time and see people with these. We've put rooms in the loft, and they've not strengthened the floor, and it's just deflecting everywhere. It's just bonkers. So the key really is you've got to strengthen. You can't strengthen the floor on the trussed roof. You can strengthen it on an older roof. So the modern loft conversion is going to have steelwork in it, and the older ones can potentially not have steel. Now, if it's not a massive span, these could potentially be flitch beams. I don't know if you've ever come across a flitch beam. Now, timber, two timbers, and you put steel plate in the middle, and you design that as a composite section. You bolt that together and they act. And the reason why builders like this is they can just lift the plate up, which is generally like sort of 10 to 12 mil thick. So that's say it was 250 deep, I didn't say. They can lift this up easy, lift that up easy, lift the plate up, and then they bolt it all together on top in the loft. So it's just a bit easier. So yeah, so they're the two sort of main options. Like I say, in the UK, the problem you have is if you have a timber frame, if you think about it, where are these steels going to sit? So that was on the elevation, say, or the part said this was on the party wall one, you've got timbers at 600 or 400 centimeters. Where's that going to sit? You'd have to go and then strengthen the wall, but you'd have to strengthen it first, all the way down to ground. Whereas with masonry, you can put a padstone in, here. The load will then spread out across the width of the wall, and it's insignificant. By the time it gets to the foundations, it's insignificant. So the additional load you're putting on the structure is nominal. But yeah, so sorry, that's all a bit messy. It's been worked out a bit messy at the end, but hopefully it gives you the gist of how you go about just planning a loft conversion. Obviously, there's loads of videos out there teach you how to design beams and stuff. That's pretty straightforward. But yeah, I'm here to just see if we can just add a bit of practical advice of how we do it. Cheers.